All right, folks, out again today, so wanted to make sure you guys had notes. So here we go. Feel free to pause, write, rewind if you have questions. All right, so we talked about exponential graphs before. We talked a little bit about growth and decay. And so if we remember, an exponential function has the form f of x is equal to a b to the x, where a is your y-intercept. Let's see. And b is the common ratio. So remember, when we talked about exponential growth, we said that b is greater than 1. And exponential decay, b is less than 1, but greater than 0. So a lot of times that might be a fraction where the number on the top is smaller than the number on the bottom, or that's a decimal like point, let's say 3. So graphically, how that looks is if I have this, we talked about this a little bit, but we left off one part that I'll add in today. So if we look at this from left to right, that's going up, right? But if you look at it from this perspective, you might think that this is going down, but it's not, because there's a such thing. It has to be moving away from the x-axis. So if you look at the first graph, as we move, that's moving this way, and x is right here, but this graph is moving away from that, okay? And again, that's from left to right. So if we look at this one, as we go from left to right, it's moving away from the x-axis. So if it's moving away from the x-axis, that is exponential growth, okay? Because you can have negative growth. Opposite of that, if we're talking about decay, make sure you're drawing these. It has to be moving toward the x-axis from left to right. So if we go and we're going that way, that would be a decay. And then a graph that's going from left to right and it's going toward the x-axis, that would be a decay. So let's separate this just a bit. This is growth. And this is decay, these two graphs. Now let's talk about the asymptote. The asymptote is a dashed line. The function approaches. I'm going to erase this because I want to write one more thing. So one other thing to note here, we talked about AB to the X. I'm going to add just a little bit more to that. So A, B to the X. And then there's these two parts, which we'll talk about later when we talk about characteristics and transformations, minus h plus k. K is where you're looking to find the asymptote. I'll just write that for you. That's the asymptote. You'll know what that means here in just a second once we start graphing. Get my word back up here. Decay. All right. Now let's get down to graphing. There's 3 steps. One is always start with drawing the asymptote. Second is create the table. So we'll go into the table in the calculator. And then 3 is plot points and draw the graph. Moving along. All right, so domain and range, we already talked about this, I think. So domain is left to right, and range is bottom to top. And we'll talk about that once we get down here to the graph. Okay, so hop on down. So I'll talk about number 1 here. I'm not going to do all these graphs. I'm going to do number 1 and 2, and then I'm going to jump down to the bottom, and then you guys can work. All right, so if we look here, we have A, we have B, and to the X, but there's not that minus H or K, okay? So I'll rewrite it here. So A, B, X, minus H plus K. So remember, we're looking to K, which would be right here if it was there, okay? It'd be right here if it was there, but it's not there. There is no K, and we know K is the asymptote. So what's the number that accounts for nothing? All right, what's the number for nothing? Some of you probably said it, it's 0. And so the asymptote is always equal to y. So in this case, y is equal to 0. Now let's talk about what that means. Remember, that's the dashed line. Even though it's 0, it doesn't mean that there's no asymptote. It just means that the asymptote is at 0. Okay, so if it's at 0, that is right here, right? Well, 0 on y. So if it was 2 on y, it'd be right here. But in this case, it's 0 at y, and it's always going to go left to right. And so left to right, we'll do it in red. You have a dashed line going right through 0 on y. Okay, so that's the first part. That's how you draw the asymptote. Now, as far as if it's growth or decay, remember, we're looking here to determine if it's going to be growth or decay. Remember, if it's greater than 1, it's growth. And so in this case, it is growth. We could wait and look at the graph to determine if it was growth, but I think it's always easier to just look right here at B. Okay, so now, next we have to create our table. So at this point, we should take out our calculators. If you don't have a calculator, probably need to pause the video, go grab one, make sure I get my calculators back. All right, so if you have a calculator, you're going to go to the table button. We should all know where that is. Okay, and so you're going to go to edit function, and then you're going to type in this 3 parentheses 2, go up to the exponent and put an x. Okay. Once you do that, you're going to keep entering. You start at 0, step by 1, whatever, right? And so you'll see 0, 3, 1, 6, 2, 12. Now, we know our graph over here is not going up to 12. The max that it's going to is 6. So we know we can't graph 212. But all we need is a couple points. So I'll talk about best practice for tables when I get back. But for now, today, we're just going to put 0 in the middle of each of our charts. We'll talk about this when I get back. Hopefully that'll be tomorrow. So we'll have 0, we'll have 1 and 2. Then obviously this is -1 and -2. Okay. Now, a couple things that you need to note here. So at 0, that's 3 that goes with that. Okay. And so we know that that is the y-intercept. 1, we know it's the y-intercept because 3 is right there. Common ratio is 2. And so as we go down, we know we're multiplying by 2, but you'll see it in the table. So we got 1 and 6. And then 2 and 12. We're not going to be able to graph that because 12 is not on there. Now, as we go up, you look at -1, and you'll see the fraction 3 over 2. So in your calculator, on the f of x side, toggle over to where your 3 over 2 is highlighted, and at the bottom, you'll see it appear again. F of x or y is equal to 3 over 2. Now, hit your toggle button. We should know where that is. It's above the equal or the enter key, and toggle that. Now at the bottom, you see that that turned into a 1.5. Okay, that's going to be easier to graph because you probably don't know how to graph 3 over 2. Now go up to -2, and you see 3/4, and you'll also toggle that, and you'll see you have 0.75. And so now we graph. So graphing, remember, you go to x, in this case it's 0, and then it's saying now that you're on 0, go up to 3 on y, and it's right there. So we'll put a point there. And then we graph 1 and 6, which will be right there. And we can't graph 2, 12. Okay? But we can graph 1, or -1, 1.5. Now, here is 1, and there's 2. So 1.5 would be just between that. So we go over to -1 on x, and then we go up. There's 1. 1.5 is in the center, so we'll have a point right there in the center. Okay, so right here in the center. Doesn't have to be exact, whatever, right? So then we go to -2, and that's 0.75. You know, I always like to think of everything in money. So 0.75, that's 75 cents. That's a little bit less than $1, so that's a little bit less than 1. So that'd be roughly a little bit above half right there. Okay, so the thing about an exponential function is the line will never go through the asymptote. It'll never go through the asymptote. So it'll continuously approach that. It'll get closer and closer, but it'll never touch it. Again, it will never touch this. It'll just keep getting closer and closer and closer forever. Okay? So what I like to do is I like to draw, knowing that I start here, and then I come and I connect it and I draw it up because I know it's never going to touch that. It's harder to draw down and swoop away. So I start this way, and I come and I connect the dots and I go up like so. There, then I go up, and there's my graph. Okay, so it approaches the asymptote, but never goes through it. So now, domain is left and right. So as we follow this, how far left is that going to go? It's going to go left forever, right? And then we follow it this way. It's going to be going up, but it's also going to the right. So it's negative infinity to positive infinity. We did talk about this. So hopefully you remember that. And it's parentheses because you can't put your pencil on negative infinity. Okay. So range, that's bottom to top. Okay. So how far down is this going to go? Now, it's not going to go down forever because we said it can't go through this, right? So the closest it could ever get is it'll keep just getting closer and closer to 0. So we know the bottommost would be 0, but not exactly on 0, so we can't put a bracket. And then how far up will it go? Well, it will continue to go up forever, so that's to infinity. Okay, let's walk through another few of them. Okay, so first let's talk about if it's growth or decay. Well, right there we have a fraction with the number on the top is smaller than the number on the bottom, so we know that this is below 1 but greater than 0, so we know that this is a decay. Asymptote, where is it? I can tell you all of these today, the asymptote is going to be at 0 because there's nothing out here. So the asymptote is y is equal to 0. Okay. Now what? Now we get our table. So you go into your calculator, go into table, clear that out, put your 6 parentheses, and then you do your fraction. So 1 over 3. And then put your x up in the exponent. Okay. And start at 0 and go from there. Okay, so in this case, there's a couple numbers on here that we're not going to be able to graph. So you know what? I'm gonna be smart about it. I said we're gonna start all of them in the middle, but I don't like that. So we're gonna start here instead, and we're gonna go down. Okay, so we have 0, 6 again, where it starts at 0 on x. That's your y-intercept. Then we're gonna go down 1 and 2, 2, and then you see we have 2 over 3. On the right side there. We have to go over to that and toggle it. So that'd be 0.66. Go down again, and we'll toggle that. That's 2 over 9, but you see it becomes 0.22. All right, and that should be enough to graph. So let's graph. All right, so first, let's draw our asymptote. Our asymptote is, again, right here at 0. It won't always be at 0, just today. There's that. It's your asymptote. And change colors this time for the graph. Okay, so we go to 0 on x and then go up to 6 on y, which is right there. So I went to 0 on x and up to 6 on y. Next, I'm going to go to 1 on x and up to 2 on y, which will be right there. So here. Now I'm going to go to 2, and then I'm going to go up to 0.66. Now that's less than 1. If it's 66 cents, it's more than 50, so more than halfway. So I'm going to be roughly somewhere off in here. And then I'll go to 3 and 0.22, which is about 22 cents, which is just below half. So we can see we're approaching the asymptote this time in its decay. So we're coming from this way and going up. And there's your graph. So domain, it's going to go left forever, so that's negative infinity, and it's going to go right forever, so that's positive infinity. I can tell you domain on all exponential functions, it's always going to be negative infinity to positive infinity. The range, on the other hand, is not. Okay. So let's talk about the range. The range, it's bottom to top. So what's the lowest this is going to go down? Well, the asymptote's right there, so we know it's not going to go less than 0. So it's 0, comma, and then how high is it going to go? It's going to go up forever. Okay. One thing I like to talk about with the asymptotes is sometimes the asymptote's going to be the floor of it. Right, you see, like, it's not going below this, right, because this is going up to the sky and this is sitting on the floor. Same thing here. Well, sometimes the graph will be down here in this area, which would make the asymptote the roof. Okay, that happens when it's a negative out here. We'll talk about that another time. So if there was a negative in front of this 6, it would make the asymptote the roof, and the graph would be down here in this area with the asymptote above it. Okay, but one thing to take note of is the asymptote, if you notice it, 0, it's in here in your range. The asymptote's always going to be part of the range. If the asymptote's a floor, well, it's going to be in front. If the asymptote was a roof, then the 0 would be over here. You'll learn that as we move along. Let's move along now to the next page. Okay, notice right here, I just said it. That right there is negative out here. So we know now the asymptote's going to be a roof. We'll see that in just a second here. We also know that this is going to be growth because that number is greater than 1. So growth. Where's the asymptote? There's nothing out here for k. So we know asymptote is y is equal to 0. Guys, take note that I'm on number 5. I'm on number 5 now. Okay. We went down. If I threw you off, take note of the fact that we are on number 5. Okay. Okay, so now we can draw our asymptote, which is, again, going through 0. It's always left to right, never up and down in this class. Algebra 2, you'll see that it'll go up and down. Okay. Now we go to our table and we enter that in. Again, feel free to pause if you need some time. I'm punching it in myself now. Okay, start at 0, step up by 1. All right, so this time I will start with 0 in the middle. And then I got 1, -2, 2, -4. 0, -1, -1. Okay, then I have to toggle that -1/2. Okay, some of you might already know that that's -0.5, so like 50 cents. Then I go up to -2 and -1/4. I'll toggle that, and that gives me -0.25. And now I can graph. Now remember, because it's negative out here, I know that my asymptote here is going to be at the top of the graph, so it's going to be a roof. Okay, because it's negative, this will now become the roof. So let's graph. We have 0 and -1, which will be right here. We have 1 and -2, which will be right here. 2 and -4, which is there. And then we have -1 and -0.5. Remember, that's in between -1 and 0, so that'd be right off in here. And then the next one is -2 and 0.25, which is getting closer to 0, so it's right there. So I know now it's, well, what happened? Now it's coming this way to approach 0, and I'm connecting the dots that way. Graph doesn't have to be perfect. All right, then domain and range. I said it's always going to be negative infinity to positive infinity. Now this is what I was talking about before, your range. I know the asymptote is going to be part of it. be 0 somewhere in the range, but because it's the floor now instead of it being in front, it's going to be, or on the left side here, it's going to be on the right side. So again, how far down is this going? It's going down forever. So it's coming from negative infinity, but then it's only going to go as high as 0 or approach 0. All right. So the next one, you can try yourself. All right. So do that. And then you have some homework. Have a great day, folks.